about something. I don't know if you guys have seen this before. I think in Math 1, you should have learned this in Math 1, but I don't know if you guys did this in Math 1 in middle school, but this was done in Math 1 and at Oxnard High School. But we're going to talk about here. Sequence and series. Sequence and series. Now, there's a lot going on here, so I broke the homework up into two different parts. Okay, I broke the homework up into two different parts. We're going to talk about sequence and series. We're going to do page 362 through 3 through 55 on, but we're only going to do 3 through 55 odd. Today, we're just going to go up to number, what do I have mapped out here? We're going to go up to number 29. So we'll try to do up to 29 today. We're going to do up to 29 today. Okay, so what is a sequence? So what sequence and series? So a sequence, we're going to talk about sequence today. Sequence is an order list of numbers. Write this down. Okay, now it's an order list of numbers that follow a pattern. You have to follow a pattern. Okay, now we can have a finite sequence, which basically means it ends. It ends. Or we can have an infinite sequence, which means it doesn't end, it goes on forever. Okay, I'll get it out of the way. It goes on forever. Okay, so an example of a sequence is just an order list of numbers. I'll let you guys write that down. We'll write some examples of a sequence. Like here would be an example of a sequence. Sorry, I'm in the way. An example of a sequence can be like 2, 4, 6, 8, and then I can keep predicting. This is an infinite because the dots means it goes on forever, right? Can you guys see? Am I frozen? Am I frozen? Shoot. Could you even see what I was writing there? Brianna, were you able to see what I was writing there, or was I frozen?
You can see it.
Okay, so you guys can see that. So I don't need a pause, Brianna. Do I need a pause, or did it just come up?
Wait, what?
Huh?
What did you say?
Should I pause, or do you need more time? Do you need more time, or are we good?
I'm good.
All right. I was wondering, so I guess I'm assuming you guys can see it, according to Brianna. If you're late in class, I didn't call roll, you got to stay after class, okay? Camila, I just saw you come in, right? You're here, right, Camila?
Yeah, I'm here.
Okay, so stay after class because I have you marked absent, and I'll forget. I forget things like this because I'm an old man. I'm old. But I'm not that old, but I'm kind of old. Almost 50. Not quite yet. I'm 47. My wife's 48, though. Older women, you know what I'm talking about. Okay, here we go. So a finite sequence, right? Oh, let me ask you. So this, can you tell me what the next number is going to be? Melissa, what's my next number going to be?
10.
10, because it's a sequence. It has an order, right? If it has no order, it's not a sequence. You can easily tell it's going to be 10, then 12, then 14, blah, 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 up till forever. So like a finite sequence could be like this: 3, 6, 12, and then 24. And then it stops. No dot, finite sequence. It's going to stop. And you can see, what am I doing to these numbers? Can you see, tell me what the pattern is? What is the pattern? Kenji, can you tell me what the pattern is for this one? What's my pattern?
Times 2.
Yeah, you're doubling it. Yep, very good. Now, finally, the last sequence, like that goes on forever. You go 1, 4, 9, 16, and you have dot, 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 dot. That's an infinite sequence because it has the dots. It shows it goes on forever. Forever. Okay. Are there any questions? We'll talk about series tomorrow. Actually, I'll tell you what a series is. I'll tell you what the series is. A series, sequence and series. So I have this. I'm going to erase this. Can I erase it? I'm going to erase it in 10 seconds unless someone says. Five, 4, 3, 2, 1. No. Okay, so a series, do it in red. A series. Okay, so a sequence is an ordered pair. A series is a sum of the sequence. Okay, so basically, well, we all know what sum means, right? Anthony, your camera's off. So tell me what does sum mean, Anthony?
Say that again?
That again. That again. If you say that again, I'll say it. That again. All right, Anthony, answer my question.
It's like what you get when you add two things together.
What?
When you add stuff together, that's what you get?
Yeah, it's just add them up, right? So basically, I just add the series up. So if I have a series 2, 4, 6, 8, that's the series. Then the sequence will be 20, because 2 plus 4 plus 6 plus 8 is 20.
It's the other way around.
What?
You wrote series as 2, 4, 6, and then the sequence is 20.
Oh, yeah, that's what I meant. The sequence is 2, 4, 6, 8. The sequence is 2, 4, 6, 8, but the series, because you add them up, sorry about that, thank you. I don't even know who said that. Whoever corrected me, you should be paid. I owe you money because I'm getting paid right now and you're not, but you should be because you corrected me. Bam! What's up? What's up, boy? What's up? What's up? What's up, boy? Boy. Flavor Flav. You guys ever heard of Flavor Flav? He's the one that goes, yeah, boy. Cassandra, have you ever heard of Flavor Flav?
No.
Well, he's a guy, he says, yeah, boy. He wears a clock. He's a rapper guy, wears a clock. Hip hop. Anyway, all right. Let's do number 3. Compare sequence and series. You guys do that on your own. I just wrote the definition down. Number 3, you compare the sequence and series. Write that on your own. Let's move on. I told you what it is. Sequence and series. Sequence is the pattern, ordered pair. The series is where you add up the pattern. Okay, so number 5, write the first 6 terms of the sequence. Okay, so they want you to write, you guys look, I feel like I should present. Can you guys see number 5? Oh, no, let's look at the instructions. Oh, my phone keeps blowing up. Okay, pow. Okay, number 5. Okay, number 5. Write the first 6 terms of the sequence. So here's my sequence. I want to write the first 5 terms. Okay, so the terms are like, well, let's explain what a term are the numbers of the sequence, right? So here we go. I'm going back. So the first 5 terms. Blink. Blink. Okay, the first 5 terms of the sequence. Okay, so now here's my number 5. I have a to the n, means arithmetic, equals n plus 2. Okay, so arithmetic means it's going to increase. You'll see. I'll explain what arithmetic means in just a second. So we want to figure out the first 6 terms of the sequence. So all you have to do okay, let's call this n. Okay, write this table out. That's how you do the first 6 terms. Okay, now let's label the term. This is going to be my first term. This will be my second term. This will be my third term, fourth term, fifth term, and then 6th term. So what's my first term going to be? My first term, what is my first term? Where n equals 1. Well, that means I'm going to take my equation and write, instead of a of n, I'll write 1 plus 2, which is 3. My first term is 3. What's my second term? That means I put a 2 where the n is. My second term is 2 plus 2, which is 4. What's my third term? I think you guys get the idea. It's 3 plus 2, which is 5. What's my fourth term? 6, 7, 8. Okay, so that's it. That's all I have to do to find the first 6 terms. Now, these are my terms. My term, first term is 3. Second term is 4. Third term is 5. 6, 7, 8. Blah, 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 blah. Now, notice that each term, I go to the next one by a addition. If I increase by addition, it is, hang on a second, I want to make sure I write it correctly. It is arithmetic. arithmetic. So that's the definition. See how these increase plus 1, if it increased by plus 2, plus 3, plus 4, if these increase by addition, it's called an arithmetic sequence. Okay. So I'm going to move on. I'm trying to find the more difficult ones. Let's see. I'm gonna do I'll do the first and last. I'm gonna do 13. I'm gonna do 5. You do the rest. I'm gonna do 13 since it's the hardest one. Okay, on that series, I'll do 13. So I'm gonna erase this in 10 seconds. Does anyone need this? Speak now. 5, 4, 3, 2, 1. No, Cynthia! And let's do 13. Okay, so 13. I'm skipping to 13 because you guys, all the rest they're pretty straightforward. I mean, I don't know. 13 is usually the hardest. So now here's it's not an arithmetic. So the other one's geometric, but this one's not geometric either. So I have 2n over n plus 2. Okay, so now again, all you have to do to find the first, what they want, the first 6 terms, n, first term, second term, third term, fourth term, fifth term, sixth term. Okay, so what am I going to do? 2n over n plus 2 is what I'm going to put in. I should have put that there. You put the equation right here. And so for the first term, you plug in, right? For the first term, that means I say 2 times 1 over 1 plus 2, right? I plug in 1 for my n. 2 times 1 is 2. 1 plus 2 is 3, so I got 2/3. That's all you have to do. Just plug it in. My second term, f of 2, is 2 times 2 over 2 plus 2, which equals 4 over 4, which equals 1. Okay? Third, fourth, fifth, and sixth term. Okay. I'm going to have you go. Okay. Let's go with Alexis. Alexis Romero.
Yeah.
Find the third term. Anthony Campos. Anthony Campos.
Yeah.
Fourth term. Find the fourth term. Brianna.
Yeah.
Fifth term.
Okay.
Camila.
Yeah.
Sixth term. All right, guys. Now these are all. This is a hint for you guys. Everyone, pick one or do all of them, you guys. As Alexis, Anthony, Brianna, and Camila, let us know. Alexis, do you know the third term yet?
6 over 5.
6 over 5, 100% correct. 6 over 5. Thank you, Alexis. Very good. Strong work. Strong work. Woo! Alexis. Okay, let's see. Anthony, what'd you get for the fourth term?
8 over 6.
Can you reduce that?
4 over 3.
Yes. Woo! Anthony. Brianna, fifth term.
10 over 7.
Yes. Very good, Brianna. Woo! Woo! Camila,
12 over 8.
reduce it.
That would be 3 over, no. That would be 4 over,
They're both divisible by, what are they both divisible by?
by 4.
All right, 12 divided by 4, 8 divided by 4 is 3 over 2.
Yeah.
I think that's right. And then I'm checking. Wait. Woo! Camila! Yeah! Strong! Strong work! Strong! Strong! I'm sorry. Nikander, was that awkward?
What?
Was that awkward? Was that weird that I did that?
Kind of.
Okay, I'm sorry. I shouldn't have done that. I shouldn't have done that. Teachers should not pose in front of their students. I think I crossed the line a little bit there. I think I shouldn't have done that. Erase that from your minds, okay? Erase it from your minds. Do me a favor, okay? Kyle, you got to erase that from your mind, man. Were you traumatized? I'm sorry, Kyle.
Yeah, yeah.
Okay, just erase it, man. Just erase it from your mind. Get it out of there.
All right.
I can assign the count. You need to talk to the counselor. I can send her over. Maybe I should do a group counseling session. I'll just have you Zoom all you guys. You know. All right. Here we go. All right. Let's go with 15. Okay. So 15. Let's look at the instructions. You guys can look at the instructions yourself on 15. Okay. Describe the pattern, write the next term, write a rule for the nth term of the sequence. Okay. So basically we want to write a rule for this. We want to write a rule for it. A rule. Okay. We want to write a rule. So we have 1, 6, 11, and 16. Okay, so what are they doing here is what they're saying. What is the sequence? Okay, so basically, like on the other ones, how we did n plus 2, we did 2n over n plus 2. So what's going on here? Sensei, you're not making any sense. I know. So I have here 1, 6, 11, and 16. And then it goes ... forever. We have to figure out the next term. So here's what I mean by what is the rule, or what they mean. Okay, let's call this n. We want to write the rule here. Now, this is going to be weird. Write 1, 2, 3. We got 1, 2, 3, 4. Okay, very carefully. Leave a blank here. Actually, let's write this as the 0 term. No, let's leave it blank. Leave it blank for now, and I'll explain what I'm going to do. Let's leave it blank. I think it'll make more sense for you guys. I have 1, 2, 3, 4. This is the first term, second term, third term, fourth term. They want to know what the fifth term is. So the first term is 1. The second term is 6. The third term is 11. The fourth term is 16. This is the first term. Term number 1. What is the fifth term is what they want to know. And what is the rule? Okay. So what they mean by the rule, I'm going to say this in a weird, because I don't know how to say it. But how do I make 1 turn into 1? And that same pattern means, how do I make 2 turn into 6? How do I make 3 turn into 11? And you're doing the same thing to all of them. I do the same thing to 1 to turn it to 1. I do the same thing to 2 to turn it to 6. I do the same thing to 3 to turn it to 11. I do the same thing to 4 to turn it to 16. And then I'm going to do that to 5 to get that number there. That's what they mean. So let's look at this for a second. What's the pattern? Sensei, you're confusing me. Just hang in there. Now, the way you can look at this is, let's look at, if I just look at from 1 to 6, how do I go from 1 to 6? What am I doing there? How do I make 1 become 6?
Adding 5.
Yeah, there you go. Add 5. I add 5. Now, if I do the same thing from 6 to 11, I'm doing really good. How do I go from 6 to 11? You add 5. 11 to 16. So on all of these, I am going to add 5. It's an addition of 5. Because I'm repeating addition. Repeated addition is multiplication. Now, you don't have to, what do you mean by that, Sensei? Well, right? Repeated multiplication, right? 5 is 1 times 5. 5 plus 5 is 2 times, you don't have to write this down. Don't write this down. 5 plus 5 is 2 times 5, right? That's what it is. 5 plus 5 plus 5, which is 15, is 3 times 5, right? Adding 5 3 times. That's what multiplication is. So what I'm doing here to get to 16 is I add 5 3 times, and it's multiplication. So what that means as part of my pattern, all that I'm saying is if you have a plus 5, if you go, see I go 5 plus 5 plus 5. If you see this pattern where I add 5, it's going to be 5 times n. To get my rule. Now, I know what you're saying. 5 times 1 is not 1, and it's 5. 5 times 2 is 10. 3 times 5 is 15. But how do I get 11? Well, a couple ways you can look at this. Let me ask you something. If this is 1, if I'm adding 5, what would, if I was to ask for a 0 term, what number would I make here to make this answer go good? What should I put in there if I got a 0 term there? If I was to go backwards, what would my 0 term be if I was to put that in? Okay, think about it. I'm going to call on one of you. No one answer it. I'm going to call on one of you. What would the 0 term be? I'm going to call on someone who I can't see. Whether your camera's off or if I just see your ceiling fan or something, I am going to call on you. Or if I just see your ceiling, or if I just see the letter A, or if I just see your curtain with pictures, or if I just see, maybe I'll top of heads I might let go by. If I see your fire alarm, your smoke detector in the ceiling, if I see that, if I see, I don't know what that is, but let's go with Liz. What's my 0 term going to be?
I'm not sure. Hold on. Wait, let me check my notes.
No, Liz. Look with me. Okay, Liz, you said I go 1 plus 5 is 6, right?
Mhm.
And then 6 plus 5 is 11, right?
Mhm.
11 plus 5 is 16.
Mhm.
What if I went backwards? How do I go from 16 to 11? What do I do?
Subtract 5.
Okay. 11 take away 5 is 6, right?
Mhm.
6 take away 5 is 1.
Mhm. -4.
Yes! My 0 term is -4. You guys with us there? Now, that helps us figure out the rule. Guess what our rule is?
Let me open my notes.
5n minus
Never
4.
called them.
Liz, do you have a question? Do you get it?
Yeah.
All right, cool. So that's my rule, 5n minus 4. Now you might be saying to yourself, what the heck is he talking about? Well, my rule is 5. I'm going to erase this because I don't need it. That means if I plug in 1 into this equation, I should get 1. Let's see if that's true. Instead of 5n minus 4, let's 5 times 1 minus 4. What's 5 times 1? 5 minus 4 is 1. Boom. 5 times 2 minus 4. 5 times 2 is 10 minus 4 is, boom, 6. 5 times 3 minus 4. 5 times 3 is 15 minus 4 is, boom, 11. Get it? So what's the 5th term? Even though we know we're going to add 5, I should also be able to go 5 times 5 minus 4. What is my 5th term? Let's see. Who do I not see? Let's see. I got 34. 1, 2, 3, 4, 5, 6, 7, 8, 9, 27. Oh. Let me try something here. Change layout. Oh, it says 42. I don't know. It doesn't have it all. All right. Anthony, what's my 5th term?
21.
There you go. Boom. 5th term is 21. So we got the rule and we described the pattern. I multiply by 5, I take away 4. 5th term is 21. And then you'll be able to figure out the 100th term. You just plug in 100, right? Okay, so let's look at, okay, so now some of these get kind of crazy. I'm going to look at, let's look at 21. Actually, you know what? How are we doing on time? 106? I want you guys to do this pattern. Let's see, that was 15. Let's do 17. Okay, let's do 17. Because it's starting to that was a very easy one. Now I have 3.1. I have 3.8. I have 4.5 and then 5.2. Let's draw our table. Okay, so I have my first term, second term, third term, fourth term, fifth term. Here's my n. What's my rule? So my first term is 3.1. Second term is 3.8. Third term is 4.5. Fourth term is 5.2. Okay. How do I go from here to here to here to here? 3.1 to 3.8 to 4.5 to 5.2. How do I do it? How do I do it? How do I do it? What am I doing? I go 3.1, 4.8, right? 4.5. How do I do it? Danielle, what am I doing? 3.1 to 3.8, 4.5, 5.2. Danielle? Ramirez?
Oh, you add 0.7.
Yeah, I'm adding 0.7. So I'm going to go 0 points plus 0.7 plus 0.7 plus 0.7. So what's that mean I'm going to do to my n? So what do I do to the n? What do I multiply n by? I just gave you a big hint. What do I multiply n by, Nikander? What do I multiply n by?
Uh, 0.7.
0.7 times n. And now figure out the zero term and figure out what you're going to add it to or subtract it to. Okay, find the zero term and then that'll be your rule. That's all you got to do. Okay, what's the zero term? I'm going to ask one of you. What is the zero term? 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 The zero term. The zero term. The zero term. Zero term. Ah. Oh. Ah. Connor, I'm playing with your sound bars there. I'm trying to make them go big. Oh. Is it loudness or is it the volume or is it how high I go? I'll sing really low. Ba. Ah. Now do it soft. Soft. Now loud. Loud! I think it's volume, Connor. I think it is. All right. Let's go with, I had someone I wanted to call. Alexis Romero, what is my zero term? Alexis, now what is my pattern?
2.4.
What?
2.4.
2.4, so I got a positive 2.4. So my zero term is 2.4, so it's plus 2.4. And that's my rule. Okay? So to figure out the fifth term, you can add 0.7, but you can also go 0.7 times 5 plus 2.4. And then you'll figure out that the fifth term is 5.9. Okay, so anyway, that's how you do it. Are we good? Raise your hand if you, I get that so far, Sensei. Put your hand in front of the camera. I get it, Sensei. All right, lots of hands. I love it. Makes me feel like I'm doing a good job, but maybe it's you guys are the ones that are doing a good job. I'm going to go with some fractions. I'm going to go with 21. Let's look at 21, okay? Now, the answers are in like on in your Canvas, so you can just go ahead and get the answers there. Just get the answers. You know what I mean? And then that'll help you with these, right? The answers, if you get stuck, look at your answers. If I'm going to do 21, I'll skip 19, do 21. "21 Jump Street." I have 1/4. I have 2/4. I have 3/4. I have 4/4. So I'm going to go, let's do our table. First term, whoops, no, wrote it wrong. First term, 1/4. Second term, 2/4. Third term, this one isn't that bad, it's just a fraction. Fourth term, 4/4. What is the fifth term? Question mark. And 0 term, what's my rule? I'm going to give you guys like 30 seconds to try to do this on your own. Okay, even though there's a fraction, all you have to do, what am I adding to it, right? Try to solve it. And then I'll just go and solve it. I'll just knock it out. "27, 27, 27, 27, 27, 27 students, 27. What is the rule? 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 What is the 0 term? 0 term. What is a 0 term? What is a 0 term? What is a 0 term? Estrella, what's the 0 term? What is the rule? What is the rule? Estrella. Estrella, what is the term? Estrella, can you hear me or no?
Yeah, sorry.
What's a 0 term?
0?
Yeah. Okay. Very good. And Eduardo, what am I adding to all of these?
A quarter each one.
Yeah, adding 1/4. Okay, so what is my rule? We have all the information we need. Let's go with, let's see. Melissa, give me the whole, what is my rule?
1/4 n.
Yeah. That's it. Plus 0 is just 1/4 n. 0 term is 0. So I'm adding by 1/4. Fifth term is 5/4. Boom. Boom, boomity, boom, 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 boom. 23's kind of crazy. And then 25. But look at, you guys know how to find the answers. What is the rule? What is the rule? What is the rule? What is the rule? What is... Now, some of these don't follow that pattern. Okay, so like 20, let me do 25 real quick. I'll just show you it because this is an arithmetic sequence where they just add, but they don't always, are not nice and neat where you just add 1/4 or add 3 or subtract whatever. I'm just going to show you real quick 25. Okay, let's look at this sequence. Okay, so 25, and then tomorrow we're going to talk about series. Remember, tomorrow's a minimum day. Tomorrow's a minimum day. So 25, the sequence is, this is 25. I have 2, 9, 28, 60. Now this, you're just going to have to figure out the pattern in your head, okay? This is not as straightforward because look, the zero term doesn't help us in this. It's not arithmetic, but I'm just going to write it anyway. First term is 2. Second term is 9. Third term is 28. Fourth term is 65. Fifth term is whatever. And zero term, not really going to help. But you can see, well, I'll pause so you guys can catch up. What is the rule? What is the rule? What is the rule? This one you can see, okay, well, sensei, we are adding 7 to this, and this one I'm adding 19. And then this, they're different. Is that 19? I think that's right. And whatever I'm adding to here, 28, what is that? 33, 43? Is it 33 or 43? 7. 37? Sorry, I was way off. But the point is, you can't see, I'm not adding the same thing. So that rule, what I showed you before is not going to work. So you kind of have to figure out, okay, what's going on here? And you got to mess with the pattern and say, okay, well, this is like 1, 8. You know what these numbers are close to? Like, I'm thinking, okay, so you got to figure out, does anyone know what this pattern, what's going on here? What do I do to 1 to get 2? What do I do to 2 to get 9? What do I do to 3? So this one, you just kind of have to see the pattern, visualize it. You have to know, I'm either squaring or cubing. I'll give you a hint. 1, 8, 27, 64. How do I make 1 into 1? How to make 2 into 8? How to make 3 into 27? How to make 4 into 64? And I do the same thing to all of those. How to make 1 into 1, how to make 2 into 8, how to make 3 into 27, and 4 into 64. And then 5 will be 125, I think. Is that pattern? Anyone know? Someone speak up so we can move on. Who knows what's going on so we can move on? What's going on?
It's n cubed plus 1.
Yes, very good, Kyle. I'm actually cubing this. 1 cubed is 1, but then I'm going to add 1 to it to get 2. 2 cubed is 8, and then I add 1 to it. So Kyle is right. So it's going to be n cubed plus 1. And then, 5 cubed is 125 plus 1 is 126. But check out the solutions to help you guys figure out those patterns. If you try to do it on your own, but if you totally get stuck, look at the solutions. What is the rule? What is the rule? Tomorrow's a minimum day. I gotta remind myself because I gotta get in here earlier than normal, right? Because I don't have first period, and I normally come in at 10. But, okay, let's look at 27. Which rule gives the total number of squares in the nth figure of the pattern, shown and justified? So basically, I want to plug in 1 and get 1. I want to plug in 2 and get 3. I want to plug in 3 and get 1, 2, 3, 4, 5, 6, right? So there's 6. If I plug in 1, there's 1 square. I have the number 2. The second term has 3 squares. The third term has 1, 2, 3, 4, 5, 6, has 6 squares. The fourth term has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 squares. Which one of these would it be? Well, if I plug in 1 here, 3 times 1 is 3 minus 3 is 0. So it's not A. The first one already doesn't work. Letter B. 4 times 1 is 4 minus 5 is negative 1. It is not B. Could it be C? 1, plug in 1, and I get 1. Plug in 2. So that one works. Plug in, this is 1 equals 1. If I plug in 2, then 2 equals 2. Nope, it should equal 3. So let's try D. Plug in 1. 1 plus 1 is 1, right? Times 1. 1 plus 1 is 2, times 1 is 2, divided by 2 is 1. Plug in 2. So it's going to be D. Does that make sense? Plug in 2. 2 plus 1 is 3, times 2 is 6, divided by 2 is 3, right? So it's going to be D, because you have here, I guess I should draw it out. I feel like I'm just showing you guys, it's kind of like not making sense. Let me just draw it out. This is 20. Let me see. Raise your hand if that makes sense, or do I need to draw it out? I'm going to look at you guys. Hang on. Wait, let me look at all you guys. Okay. Raise your hand if that makes sense. You don't need to draw it, Sensei. It makes sense to me. If I don't see hands up, I'm gonna go over it, which is fine. Okay, I see half of you do not raise your hands, so I am going to teach. Since half of you don't know it, I am going to teach it. So I have here, here's my pattern. My first term is 1 square. My second term, I got 1, 2, 3 squared. My third term, I got 1, 2, 3. I got 1, 2, and I got this. And then my fourth term, do I want to draw that? Hang on, I'm still drawing it. Okay, so, and then I'm saying it's D, because it's, and I'm just writing all this stuff down so I can, n times n plus 1 all over 2. Okay, what is my pattern? Base of n. Okay, I'm back. Okay, so I drew it all out. Look, I drew it all out. Look how cool I am. So let's make a little table so we can focus on what's going on here. I have here on my table, I have my first term. I don't need to do this because second term, third term, fourth term, and my first term, I have 1 square. First term should equal 1. My second term, I have 1, 2, 3 squares. So my second term should be 3. My third term, I have 1, 2, 3, 4, 5, 6, 6 squares. My fourth term, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10. Okay, so I'm saying that D is going to work, right? Let's see if D works. So if I plug in 1, I should get 1. Let's do 1 times 1 plus 1 all over 2. 1 plus 1 is 2 times 1 is 2 over 2, and I get 1. So that looks good so far. My second term is 2 times 2 plus 1 all over 2. 2 plus 1 is 3 times 2 is 6 divided by 2, 6 over 2. And I got 3. Boom, that works, right? They should all work, so it's going to be D. D is going to be my pattern. I mean, you can plug in 3 if we want. 1 times 3 plus 1 all over 2. 3 plus 1 is 4. Divided by, wait, 3 plus 1 is, oh, I'm sorry. It's supposed to be 3 here. 3 plus 1 is 4 times 3 is 12. Divided by 2 is 6. Boom, that works too. Okay, so that's your answer. Anyway, that's 27. That helps us. That's a multiple choice. Hopefully you can see why it's D. I don't know. Are there any questions on that? I feel like I'm spending too much time on that one. And then we're going to stop at 29. I wonder if I should just let you guys do 29. Okay, modeling with mathematics. Rectangular tables are oh, look, I need to present, sorry. Rectangular tables are placed together along their short edges as shown in the diagram. Write a rule for the number of people that can be seated around end tables arranged in this pattern. Okay, so you can see the first term, the rule. So the number of people are how many chairs there are going to be, right? The first term is going to have 1, 2, 3, 4, 5, 6. 6 people. But then you add another one and you take away a chair and you add one over here. So 6. You got 10. And then this one, right? So let's see if we can figure out the pattern here. So I'll let you guys, I'll get started, and then if you guys want to continue, you can. But I'm writing on the board as I'm looking at the problem here. So I can see, I'm just going to write my terms based on chairs. Okay, my first term, 2 tables, 3 tables. Okay, so the first table has 6 people. The second table, I'm looking at the tables, I'm counting them out. We got 1, 2, 3, 4, 8, 9, 10. The second table I have 10. The third one I have 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 14. Now, am I? Oh, this one's actually pretty darn easy. Every time, actually, I think, should I let you guys want me to show you? Do you guys see the pattern here? You can see that each one of these I'm adding by 4. Well, what's my 0 term? And then you can figure it out that way. So I want to do it at the beginning of class. That's it. I'll let you guys figure that out. You guys figure that out on your own. This is all you did at the beginning of class. Same thing. Same thing at the beginning of class. You guys have any questions? I don't have anything else. We're going to stop at 29. We'll do the rest tomorrow. There's no check your understanding today. You guys are good. That's it. If you have questions about the test from yesterday, see me after class. Juniors, make sure, actually juniors stay after class too. Let me talk to the juniors. And if you're absent, you stay after class. Juniors, please stay after class. I won't be much long for the juniors. Juniors, I'll handle you first. Okay. And if you're late, I marked you absent, so stay after class. Okay, so juniors stay. Everyone else, are there any questions? I love you. I'll see you guys tomorrow. Juniors, stay real quick though. See you guys tomorrow. Bye, Lilia. Bye, Danielle. Bye, Jada. Bye, Nikander. Bye, Connor. Bye, Naveed. I love you, Naveed. Okay, juniors, just real quick. All I need you to do is check to see, right, raise your hand if you already saw the Google Classroom. If you have your Google Classroom, I'm in it. I'm done. Okay, if you got your Google Classroom, you can get out of here. Don't worry about it. If You can go. I'll see you guys. If you need help with your Google Classroom, let me know. And otherwise, I'll see you. And then people who are I marked absent, make sure you stay. Okay. Okay. Who is here? Who did I mark absent?
Me.
Who is that? I'm not looking at you right now. I'm just in my attendance.
Alexander Garcia.
All right. Oh yeah, Alex, you came. Remember you coming in late.
Me too, Kimberly Garcia.
Who is that?
Kimberly Garcia.
Kimberly. All right, Kimberly. Are you guys related?
No.
Huh? All right.
No.
All right. Well, just wondering. You're both late and you have the same last name. All right. Anyway, I'll see you guys tomorrow.
You too.
Unless you have questions.